Today we're going to talk about savings accounts. Okay, so we'll start with a quote from Alan Greenspan, who was our national economist at one point. Anything we can do to raise personal savings is very much in the interest of the country. So one of the problems we have here is that the average person can't pay a $500 unexpected bill. Okay, they don't have $500 in savings. You need to put money away in savings. You need to start as soon as you get a job and put money away in savings, and that's for unexpected, extremely important things, okay, and nothing else. You should always have money in a savings account. Okay, what if you said you wanted to be a millionaire? Here's an idea, okay? Here's tip number 2. Set a budget. People hate to budget. It's not fun to budget. People like to just spend money. But the problem is the money comes in, the money goes out. People live to the limits of their income, okay? It is critically important that you budget. So before you spend your whole paycheck, you need to sit down. You need to thoughtfully budget for the month. You need to keep a spreadsheet of your expenses so that you can make a realistic budget. And then you need to stick to it. Your budget should include putting money in a savings account. It should also include things like entertainment, okay? If you don't budget money for entertainment, you're going to go have entertainment anyway. You're going to spend money on that, and then it's going to blow up your budget, and your budget's not going to work, okay? So you need to budget for that. You need to budget a miscellaneous expense. You need to budget savings, on top of all your stuff that you got to pay, utilities and rent and all that kind of stuff, gas, okay? So, very important, set a budget. Okay, a savings account. What's a savings account? It's different from a checking account. A savings account is an account where the bank will pay you interest for the use of your money. When you put your money in the bank, that money does not stay there, okay? So if you went down to a bank down here in town, and that bank might on paper have $1 billion worth of assets in it, but it probably has no more than about $20,000 to $40,000 worth of cash in the bank, okay? Because they take that money and they lend it out. It's that you go to the bank and you want to get a mortgage, or you want to get a loan for a car or whatever. That's where the money comes from. It comes from somebody else's savings account. You borrow it at 6 or 8 or 10%. They pay that person 1 or 2% in interest, and then they keep the difference. Okay. They charge those customers interest for the use of their money, or they pay those customers interest for the use of the money, and they charge their borrowers interest for that money. So some terms you need to know. This is a really important one. Principal. Principal is the amount of money that you deposit into an account, okay? So if you go to the bank, you take $1,000 down there, you put it in your savings account, that's your principal. If you get some interest, say you got $50 worth of interest for the year, so now you got $1,050 in there, that's your principal, okay? If you go to a bank and you borrow money, say to purchase a house, the amount that you owe to the bank is the principal. Okay. Interest. Interest is the money that the bank pays you to borrow your money. Either that or it's the amount of money that the bank charges you to borrow their money. There's 2 kinds of interest. There's simple interest and there's compound interest. If you're borrowing money, you want to pay simple interest. If you're getting money, you want compound interest, because compound interest tends to be more money, okay? Banks are always going to charge you compound interest virtually every time. We'll talk about those in the next few pages. So your interest rate. The interest rate is the rate at which the bank charges or pays you to borrow money. Interest rates can vary anywhere from 1% to 24% depending on what type of loan is being made. So if you're getting a mortgage, that's generally a very safe loan, especially if you're putting a lot of money down on the house. Your interest rate is going to be like 3.5% to 4% right now. If you're getting a credit card and you've never had one before, that's a pretty risky loan for the bank. You're probably looking at 22 to 24%. Okay, that's why you don't want to be in credit card debt. Credit cards are the worst. They're the worst account for charging you high interest. Okay, you don't want to keep a balance on your credit card because that's money that you're just paying out so that you can use somebody else's money. Not a great idea. APR. This is one that's extremely confusing for people. APR, your annual percentage rate, is often thought of as your interest rate. They are not the same thing. APR takes all the interest that you're going to pay from your interest rate, and it adds on top of that any fees that are involved in obtaining the loan. So if you have to have an appraisal done, if you get charged a lender fee, if you get charged an escrow fee or anything like that, that all gets added on top of the interest, and then that's your APR. So let's say you went and got a loan and the interest rate was like 3.25%. If you got a good loan with a legitimate company, you're probably looking at an APR of like 3.35% or something like that. It's going to be a little bit higher than your interest rate. If you get a loan and your interest rate's like 3.5% and your APR is like 7%, there is a big problem somewhere. Somebody's ripping you off. Okay, so be really careful. The lowest your APR is going to be your interest rate, and that's if you're not paying any fees to get the loan. Okay, a money market account. It's very similar to a savings account, except it has more restrictions. Usually has a slightly higher interest rate, so you're going to make a little bit more money, not a significant amount on a money market account than you would on a savings account, but you'll get a little bit more money. The difference is you have more transaction restrictions. So it could be that you only can do 5 transactions a month, or it could be that you have to do transactions of a certain size. Maybe it's a minimum transaction of $500 or something. So otherwise, they're very, very similar to a savings account. Now, a CD, called a certificate of deposit, this is another fixed rate product that people invest in. Generally, they're people who cannot afford to lose their money for any reason. So they're pretty safe investments, but you don't get very much interest for them. And the bad part is your money is tied up for whatever the length of the CD is. You can't get your money out. If you have to get your money out for some reason, it may be impossible. It may be that you have to pay a big fine, a fee, or something like that. Not the best investment for most people. Okay, we're going to shift to something called an arithmetic sequence. Okay, what is an arithmetic sequence? An arithmetic sequence is a sequence of numbers where each term has a common difference. So if it has a common difference, it's an arithmetic sequence. What is a common difference? If you take any two consecutive numbers in the sequence, and you subtract them, you will always get the same number. Okay, we'll look at an example of that in just a second. An arithmetic sequence also has an initial term, which is just the first term in the sequence. Sometimes they have an ending term, sometimes they don't. So the sequence can be either finite or infinite. So let's look at this one. The sequence is 7, 11, 15, 19, 23, to 63. Okay, what does this tell me? Well, the first thing I look at here is I look at the difference. The difference is 4. The difference is 4. The difference is 4. The difference is 4. So every piece of evidence that I have tells me this thing has a common difference, which we call D, and it's 4, and that tells me it's arithmetic. Okay? Now, this number out here by itself, that's just the end. So this is a finite. Because this has an ending number, this is a finite sequence. Excuse me. So I know what the common difference is, D, and my initial term is just the first term. That's 7. So we write that as a sub 1 is 7. Okay, a sub 2 would be the 11, a sub 3 would be 15, a sub 4 would be 19, a sub 5 would be 23. I don't know what this one is because there's a bunch of stuff missing. What these dots mean is there's a bunch of numbers in there. They're all separated by 4, but I'm just too lazy to write them all down. Okay, or it's too long for some reason. Okay, now let's look at this one. So if I look at this, the difference there is 4, difference there is 4, difference there is 3. That tells me this is not an arithmetic sequence because that one's different than the other ones. Doesn't matter if they're all the same except for one, it's not an arithmetic sequence. Okay? Because it does not have a common difference. It is finite because it ends at 25. It does have an initial term of 4, but no common difference, so not an arithmetic sequence. Okay, let's look at this one here. So I look at this, difference of 2, difference of 2, difference of 2, difference of 2. No more numbers. Well, there's a bunch of numbers. This tells me this goes on forever. This tells me it's infinite. So it's infinite, and as far as I can tell, this is an arithmetic sequence. It has a common difference of 2. It has an initial term of 6. Easy peasy. Okay, let's look at something. Let's look at the formula for an arithmetic sequence. So a sub 1. This is called the initial term. It's the first term of the sequence. Okay, whatever that first term is, that's it. The second term is going to be the first term plus a common difference. So let's say, for example, let's say we had an initial term of 8, and we had a common difference of, say, 3. Okay, so the first term, a sub 1, would be 8. A sub 2 would be the first term, 8, plus the common difference, which is 3, so that would be 11. A sub 3 would be the first term plus 2 common differences. Okay, so a sub 3 would be the first term plus 2 common differences of 3. 2 times 3 is 6, plus 8 is 14. So there's the third term. The fourth term would be the first term, 8, plus 3 times the common difference, which is also 3. So that's 9 plus 8 would be 17. And it just keeps going like that forever. Now, if you look here, the fourth term has 3 common differences. The third term has 2 common differences. The second term had 1 common difference. The first term had no common difference. Okay, let's be really careful about stray dots on this because we don't want to get the wrong impression. Okay, so we get this formula, and this is an important formula. You should know this. A sub n is equal to a sub 1 plus n minus 1 times d. What does that mean? This means the nth term, so it could be the 15th term, is the first term plus 15 minus 1 common differences. So that would be the first term plus 14 common differences if I had a sub 15. Okay, if I had a sub 73, that would be the first term plus 72 common differences. And that formula allows me to calculate, if I know the first term and the common difference, I can calculate any one of these without having to count them up and go, okay, 8, 11, 14, 17, 20, so on and so forth for 73 numbers. It's a great shortcut. Okay. So let's look at this example right here. Lisa has a glass jar in her office, and she's going to collect coins. She starts by putting in $11.25. So she's got $11.25 in her pocket. She throws it in the jar on the very first day. Now, she's going to add coins to this jar every day because she has to commute to work, and she always gets 70 cents in change. So she takes the 70 cents and she throws it in the jar each workday. So after 100 days, she'll take all that money to the bank and deposit it. So we're going to figure out how much money she's going to have after 100 days. Okay, so if we go back to our formula, this is going to be an arithmetic sequence because she's putting the same amount, 70 cents, in there every time. So it's not a bad idea to write down the formula. A sub n equals a sub 1 plus n minus 1 common differences. Okay, because remember, it's n minus 1 because the first term doesn't have a difference. It's just whatever it is. So if I look here, a sub 100, so 100 days, she's going to have put $11.25 in there on the first day. And then on the 100th day, it's going to be 100 minus 1 common differences, and the common difference is 70 cents. So this becomes 11.25 plus 99 times 0.7. So I get out my handy-dandy TI-84 plus C Silver Edition graphing calculator, and I figure out what that is. So this is $11.25 plus $69.30. So she will have $80.55 on the 100th day. Okay. This is your turn, so here's what I'm going to do. We're going to read the problem through, and then I'm going to let you pause this and figure it out, and then I turn it back on, and you can see what the answer is. So an arithmetic sequence has a first term of 25 and a common difference of 3. Find the 50th term in the sequence, and then identify if the sequence is finite or infinite. Okay, so go ahead and pause this for just a second and figure this out. And then when you're done, unpause it, and we'll get the answer for you. Okay, so let's get our formula out. A sub n equals a sub 1 plus n minus 1 common differences. So we want the 50th term in the sequence, so we're going to do a sub 50. That's going to be the first term, that's 25, plus 50 minus 1 common differences, and the common difference is 3. So this is 25 plus 49 times 3. 49 times 3, that's 147. 25 plus 147 is 172. So the 50th term is going to be 172. Okay. Now, identify it as finite or infinite. Probably not a great question with this, because if it's the 50th term and that's it, that's as far as you're going to go, it's finite. But you could keep adding 3 forever if you wanted to. If this is not the last term, then this could be infinite. It just keeps going on forever and ever and ever. So I guess that answer is going to depend on how you look at the question. Okay. Next topic, let's talk about simple interest. We got this formula right here. I equals P times R times T. So I stands for interest. P is principal. R is your interest rate. And T is your time in years. Okay, so interest equals principal times interest rate times time in years. All right, so let's calculate the interest on a loan of $10,000 with an interest rate of 6% for 5 years. Okay, this is simple interest only. So my interest will equal my principal. You should always write the formula down first. Let's just go ahead and do that. Always write the formula down first. So my interest is going to be $10,000 because that's my principal, times my rate. Now 6%, make sure you write that correctly. 6% is 0.06. Don't put a 6 there. And then my time in years is 5. And all I got to do is multiply that together. So 10,000 times 0.06 times 5 is 3,000. Okay, now be careful when you read the question to answer the correct question. Okay, this one says calculate the interest. I did calculate the interest. I'm done. I could have just as easily said, how much money will you have if this happens and you don't take any money out? That's a different question. I would have to take my interest and I would have to add it to my principal and I would have $13,000 then. So make sure you read that question very carefully. Example 2. Mitchell deposits $1,200 in an account that pays 1.5% simple interest. He keeps the money in the account for 3 years without any deposits or withdrawals. How much will be in the account after 3 years? This is that second question I talked about in the other one, so you got to be very careful. We're going to use the same formula. I equals P times R times T. So the interest will be the principal, $1,200, times the rate, 0.015. Okay, a lot of people put 0.15 for that. That's 15% interest, guys. Be careful about that. Okay, and then time in years is 3. Okay, so I'm going to calculate the interest. 1,200 times 0.015 times 3. That's $54. So he's going to get $54 in interest. Now, how much will be in the account after 3 years? Well, he's going to have the original $1,200, plus he's going to have $54 in interest. He's going to have $1,254. How much simple interest would $800 earn in 300 days of a non-leap year at an interest rate of 1.71%, round to the nearest cent? Okay, we've got to think about this question for a minute, because notice it's not in years, it's in days. Okay, so I get my formula. Interest is P times R times T. How much simple interest? So I'm calculating I. My principal is 800. My rate is 0.0171. That's 1.71%. Now, what goes here? It's not 300. It's 300 out of 365, because there's 365 days in a non-leap year. Okay, so wouldn't be a bad idea to calculate that first. 300 divided by 365. Okay, for ease sake here, I'm just going to round this down, but you can leave the number in your calculator. Okay. So I'm just going to take that number times 0.0171 times 800. And I get 11.243. Now, that's to the nearest cent. That's $11.24. That's how much interest I'm going to get. How much principal must be deposited to earn $1,000 simple interest in 2 years at a rate of 1.3%, round to the nearest cent? Okay, this is the type of question which I like to make sure that I write the formula down, because the formula tells me where all the numbers go. Okay, how much principal must be deposited? That means I'm solving for P in this one. I'm not solving for I. I need to earn $1,000 in simple interest. So the $1,000 is the interest. My rate is 0.013. And my time, T, is 2. So let's see. If I multiply these together, this is going to be 0.026 times P equals 1,000. And now I'm going to divide both sides by 0.026. And P is going to come out to be 38,461.54. So I need to put this much money into my account if I'm going to get 1.3% interest, and in 2 years I want to have $1,000 worth of interest. Okay, how much principal must be deposited in a 2-year simple interest account that pays 1.75% in order to earn $300 in interest? So on this problem here, I'm going to let you pause this and then solve the problem. And then when you're done, unpause the video and check it against what I have up here and see how you do. Okay, so pause it now. Okay, so here we go. Again, I'm going to write down my formula because it helps me solve the problem. Okay, how much principal? So that tells me P is my variable. I have a 1.75% interest rate. That's 0.0175. It's 2 years, and I want to have $300 in interest. So I get out my calculator. 2 times 0.0175. That's 0.035 times P equals 300. And now I'm going to go ahead and divide by 0.035. 300 divided by 0.035 is $8,571.43. Derek has a bank account that pays 2.1% simple interest. The balance is $910. When will the account grow to be $1,000? Okay, so again, same thing. Write down the formula. Interest is principal times rate times time. Here's my rate. So I'm going to go ahead and put 0.021. Okay. He has a balance of $910. That's the principal. He wants the account to be $1,000. That means my variable is going to be T. I'm going to figure out how long that's going to take to do that. So the first thing I do is I multiply this together. 910 times 0.021. This comes out to be 19.11. T is 1,000. Now I'm going to divide both sides by 19.11. And I get T is 52.3. And that would be in years. That seems a bit excessive. Did I make a mistake? Let's double check this. So, the principal is $910. The rate is 2.1%. Wants to have $1,000. 910 times 0.021 is 19.11. 1,000 divided by 19.11, 52.3. Okay, there we go. Takes a long time. How long will it take $1,000 to double at 11% simple interest? Okay, so again, we write down the formula. Oh, wait, I've discovered my mistake. We don't want $1,000 in interest. How much do we want in interest? We want $90 because we want to have a balance of $1,000 when it's done. That's why this took so long. Okay, so 90 divided by 19.11 is 4.7 years. Much better. Anybody can make a mistake on stuff like that, so be really careful. Okay, and you got to be careful because, you know, what happened? Why did I make a mistake before? Because I didn't read the question correctly. Okay, when did the account grow to be $1,000? I put that in for the interest. That was when it would earn $1,000 in interest would take 52 years. Okay, so be really careful with that. All right, let's go back to this one. How long will it take $10,000 to double at 11% simple interest? So I definitely know that there's an 11%, so that's going to be 0.11 for R. How long will it take? That means I don't know what the time t is. My principal is going to be 10,000. Okay. Now, what's going to go in for I? Well, I want to double the account value. So that means it's got to be worth $20,000, which means I need $10,000 in interest over here. So my interest plus my principal will be $20,000. So 10,000 times 0.11, this is 1,100, T equals 10,000. And then I divide by 1,100. So 10,000 divided by 1,100 is 9.09 or 9.1 years. Example 5. Carrie invests $5,000 in a simple interest account for 5 years. What interest rate must the account pay so there's $6,000 at the end of 5 years? Okay. Here's my formula. Puts $5,000, that's my principal. The account, let's see, what interest rate must the account pay? So I don't know what R is, so R is my variable. I know I have 5 years to do it in. That's my time t. And I need to have $6,000 at the end, which means I need to have $1,000 in interest to add to my principal, so I is going to be 1,000. So I can do this easy enough. That's going to be 25,000 times R is 1,000. I'm going to divide both sides by 25,000. And I should get a decimal. 1,000 divided by 25,000 is 0.04, which is 4%. Okay. Again, this one right here, I'm going to let you do this problem on your own. So I want you to pause it here. Let's do this problem, then come back here, and we'll look at it together. Okay, so hopefully you wrote down the formula. I equals PRT. Marcos deposited $500, so there's my principal, in a 2.5-year simple interest account. So that's my years is 2.5. He wants to earn $50 in interest, so the $50 is going to go right there, and we got to figure out what interest rate he's got to get, so that's my variable R. Okay, so the first thing I need to do is multiply these two numbers together. 500 times 2.5 is going to be 1,250 times R equals 50. Then I'm going to divide both sides by 1,250. 50 divided by 1,250 is going to be 0.04 again, which is 4%. Okay, now you're going to do page 17 of your packet. Good luck with that. See you in class.